Hey everybody, Justin here down in the electronics workshop. So I'm working on a little bit of a project here, building a battery for the Anritsu, my spectrum analyzer, the Spectrum Master. I went ahead and pulled out the removable battery from the unit because it just does not work. It doesn't take a charge. It has some issues. So I wanted to get into see if I could potentially build a pack for this, and it looks like I should be able to. This battery pack was originally produced or made by a company called SM-Energy National Power Corporation. The battery is an 11.1 volt, 70 watt hour configuration. The model is SM204. Now, here's the thing. This is basically just a laptop battery, 11.1 volt laptop battery. There's absolutely zero reason these need to be super expensive, other than the fact that, the company that is making this form factor appears to be kind of a standard to test equipment of the Anritsu brand. Now, I don't know if this is a matter of what happened was this third-party battery manufacturer, whoever they are, got wind or knows that this is a piece of test equipment and they can price gouge the battery like you wouldn't believe. So it's a little disappointing, but I should be able to remake this pack. A few things that I'll be doing here, so we'll break this down to what the battery is. It is breaking it down to its elemental bits. It is called a 3S, so that's 3 batteries in series, 3P, 3 batteries in parallel configuration, which should be getting to the point of a 70 watt hour 11.1 volt battery pack. You have a little bit of a protection board. I don't think this does any balancing, or maybe it does, but we have a battery protection board here, as well as a charge indicator side on it. It is a soft flexible PCB. They have it coated in a little bit of Kapton tape as well, trying to keep and isolate some of the electrical components from getting in contact with the housing of the battery. So that was just lying on top of the cells themselves. So it does not appear to be the type of battery board that would likely give me any issue with protection or the anti-repairability side of things. It's a thing, but I did test this pack when I removed and disassembled it. These 2 batteries, these sets of batteries here, are fine. The middle one is completely dead. So there's either an internal short or something's up with it. It's just not happy. So I went through and I did a little bit of organizing, and I came up with a bunch of my batteries that are salvaged batteries, of course, that I test and I grade them to make sure that I can get a safe battery to build. And I use a little program called Repacker. So it's repackr.com. After I go through and I grade all my batteries, I discharge them, I make sure that they have a decent or usable capacity. They don't show signs of overheating, leaking. Go through and I do some resistance testing, so I'll do a full charge on it, I'll let it sit, and then I will see where the voltage levels out. So it's just a long process of grading to use and reuse battery cells. There's absolutely nothing wrong, by the way, with reusing battery cells as long as you do grade them properly. So we're getting close to the point where I'm going to start assembling a pack now. So one of the first things I need to do is I'm going to go above and beyond on this design, because obviously I want to use this frequently. So I have these little fish paper insulators to go on the batteries themselves. Now these batteries, by the way, I re-wrapped. So I actually do pull the original wraps off of them, mainly because they usually get destroyed when I'm when I'm stripping down the batteries themselves, they have usually some contact adhesive or super glue or whatever crazy glue that they use to put them together. But anyway, I went ahead and stripped these down. I polished up the terminals on top so they take spot welds fairly decently. And now we're to the point where I got the fish paper rings on them. And we got to grab some nickel strips. I'm using some stuff that came with my glitter spot welder. It's just a thinner stuff. It's the same size, but a little thicker than what they used on the pack originally. So that's what I will be using to assemble this. Now I may have to do some calibration on the spot welder because I did use it for some NiCads recently, and I needed to use a little less power. So we're gonna we have to bump that up. Oh, foot pedal. Yeah, forget about that. We're gonna go ahead and put the foot pedal down on the ground. I will say I like this little thing. I like this spot welder, but they could have made the cables a little longer for the power supply. They definitely do not quite... They're not very... the cable's too short. I have to run an extension on it all the time. And here's the other pet peeve about this product. They give you the little thing to line up your cells. They have this housing for your... But it doesn't touch or reach the cells. So, and the base isn't that tall that it would cause that problem. So they've kind of, it could be a little better, but the thing works great, by the way. I'm not gonna gripe about that. I'm happy I have it. I need something to prop up my battery cells on so that I can spot weld. I need to just come up a little bit. I think I've got just about the perfect thing to accomplish that goal, and that is too tall. Oh, fun. Somebody needs to be talked to at the company about their processes, because that is annoying. Can I use the original battery housing flipped upside down? Thing is, it's going to be crooked, of course. Maybe the other side. That'll work, I think. Okay, back on track. So let's go ahead and I'm going to set this. I know you're not going to be able to see this, but manual trigger. Okay, I need to get into there. I'm going to bump that up to 30. I think that was my go-to before. Manually triggered. I think we're up to voltage. And I will say again, I have already...
Good afternoon. The time is 3 p.m. Weather.
6 meter repeaters talking.
Temperature 78 degrees.
As I was saying before my repeater rudely interrupted, these cells have all been charged and equalized, and any amount of difference in the voltage right now isn't going to matter. There's not enough current that's going to be discharged when making these connections that it will be a problem. So here we go. And that's too much. So we got to back that down. I think I'll take that back down to, let's try 15. We just blew right through, which is okay. I can compensate still. That's better. Now, I usually go for line up the last cell. We want these to be as close together as possible because the pack is going to be a bit of a tight fit. And I think I'll double punch these with in a minute anyway. That seems sturdy enough. Now we'll double punch them. There's a handy little guide apparently built onto this. Not what I was planning on using for spot welding, but it works. Oh, there we go. And then I double punched that one already. Cool. So now I can go ahead and trim this excess lead off. Because we've completed that side of the battery. Now we'll flip it over and we'll do the other. Bottom's a lot easier to do, and I don't need the fish papers on the bottom traces, mainly because it's not going to get into anything like the center post would. There's that. And oh yeah, I should have aligned that better, but I will make do. It'll be fine. Okay, and I feel pretty good about that. So that's one pack of 3 done. Rinse, lather, repeat. I had a feeling this machine was designed for a left-hand user. I think I'm going to make a change in my plan. We'll work from the right. This cable is inconvenient. You eagle-eyed viewers out there are probably yelling at me, dude, you forgot to put on the thing. Yeah, okay, I forgot. Let's do that now before we get too far. Glad I caught myself, though. Otherwise, I probably would have been angry. There. I'm always in a rush. Alright, back to the original plan. double tap these right away. Cool. And the other side. So there's already a fish paper on that one. That was from a previous pack that I was working on. I'm gonna leave it on. It's not gonna affect anything, but yep, I know it's there. It is not the positive. And we'll double tap these right away. Good deal. Hang on to those because those will make good solder tabs for the for other stuff. Next. Hey, and we better put these on before I forget. They just add a bit of extra insulation in case there is an abrasion or it wears through. Okay. I'm a bit anal, so I'm gonna turn these all so I can see the capacity of each cell in case I ever have to touch these again. Where are these stupid fruit flies coming from? And because we're here, double tap. Okay. That's good. Okay, this fruit fly, pissing me off. All right, now we have the structure of our pack kind of figured out here. We have three parallels all done. Now we need to work on the next part of this. Is we need to bridge certain bits and boobs. And the way that I think they did that was they laid them flat against each other like this, and they made it like that. So that means we'll do the same thing. Only problem, because this stupid spot welder is too darn freaking high, I've gotta fiddle around a bit too much. Okay. And of course I've got to run it this way. I'll have to try to tap that a couple of times to get it perfect and stuff, but I think we'll be okay. Yeah, that's not the nicest way of doing it, but it'll work. All right. So that's one side done. Now we gotta flip it and do the other. That means if this side's towards me, all right. And that's towards me. And this goes there. Gotta be pretty darn careful to not bridge the wrong part of this battery. Otherwise things get exciting. Okay. So essentially we have rebuilt the pack. Now we just need to put some some wires on it, which I think we will go ahead and do right now. I'll warm up the soldering iron. Should be done with the spot welder for now. Normally I'd use these as solder tabs because, well, I really don't have any need for other stuff, but they used the wires. I'm going to use the wires. I'll just transfer over their wires. Keep your heat short. You do not want to dwell on these. It's not good. Which is why I like solder tabs. Okay. I did that wrong, didn't I? Yes, I did. Oh well, let's try it again. This way. It's not too wrong. I mean, it's definitely going to be fine, but just on the wrong side. Trying to duplicate their pack identically so that you don't have too much fiddling around to do. And there. Okay, we'll flip it. And then we'll flip it. And then we'll transfer over the other ones. Again, be careful. You're working with a live pack right now. All right, so we're done with this for now. We don't need it any further. But what we do need is to lay the pack flat. And we'll tape it. To get everything squared away. So here's my Captain tape. What I'm going to do is end to end try to wrap this so that it's tight. And that should be just fine. I'll just have to cut and pull that through because it's going to get caught in the Captain tape. But the rest of them will not. Good enough, not pretty, but it's going to be in a housing, nobody's going to see it. Except for this one time when I built it on camera. Just get things to kind of sit where they need to. Cool. Now we're to the point where we have to put this on, and it's gonna go a little something like this. That. I think the first thing we're gonna want to do is put the battery in here. Because we'll probably have to do a little bit of compressing of the cells to get everything to fit nice inside of this housing, because things might be just a little tight. Oh, that was easy. Must have built the pack all right then. The reason why I wanted to do it that way was so that I could slip these in so that things are a little safer as well, while I shimmy everything in place. And that should work. I can seat these all the way. Looks good. And then I can solder down all the other stuff. I'm going to use a little bit of tape to hold it in place, because they did, and so shall I. Okay, that's looking good. Now let's just solder on the stuff, and then we can pretty much be done with this. Test it in the box, and make sure the voltage is correct, of course, before we plug it in. Alright, this probably needs to be waken up, which means you have to apply power to it, because it's currently not showing any charge status, which I kind of expected it would do, because that's how BMSs normally act when they're disconnected. You need to apply a bit of charge to them to get them to take off, but I'm just getting rid of some of this excess tape so I can pop the cover on. Okay. Yeah. Groovy. I'm gonna have to do a little bit of work on this housing to get things to really work together, but I might just wrap it in some thin tape. Okay, let's check the pack, make sure we got it wired right. It should be fine. I was pretty darn precise about my operation, so we should have 4.2, 4.13, should be 8 point something, 8.28, and then this should be 11 point something, 12.37. Perfect. Looks good. Now, let's pop this in the Anritsu, because we know that that's fine. And I'll hook the charger up to the Anritsu. Oh, one thing I definitely want to do, because otherwise getting this thing out of there might be a real fun thing, would be, I should wrap this real quick. I'm not going to fully wrap it up, but enough that it's not going to come apart while I'm putting it in the box for testing. Because that would kind of suck. Mostly for getting it out, because there was a little tab on there that you could pull when removing it that I'll have to put back on somehow. Maybe one down the middle. I'd like to try to reuse the sticker, or at least where the battery charge percentage thing is. But if I can't, well, that's not a big deal. All right, here we go. Whoa. Which way does this plug in? Like this. Okay. Hey, it powers on. Let's put that thing back on that I just ripped off for the darn stand. Hell yeah. What the heck? How in the French toast? There. It boots. It's not plugged in either. Yay! So that's a battery. Now, let's see if it shows charge. And it does, it shows a full charged battery. Let's go ahead and plug in the power now. And it shows it's charging. Sweet. Oh, you have no idea how stoked I am about this. So this is going to open up the possibilities for what I'm going to want to be doing with this piece of this test instrument. I need to use this up in some remote locations where I don't necessarily maybe don't have access to power, or it's just a quick test and I don't want to have to go find an outlet. So this will be really nice if I'm driving around, although I have the 12-volt adapter for it. But if I'm driving around doing some signal tracing or fox hunting, I will be able to I'll be able to kind of find potentially that signal a little bit easier. So very cool. Anyway, hope you guys enjoyed. I know this was a little bit of a longer video, but I kind of covered a few of the bases of my battery manufacturing stuff that I do. There's going to be more of that, I'm sure, in this. This is mostly, I just do this out of pure necessity, and I like to recycle batteries from equipment that generally would just get, they end up in landfills. They end up getting just completely destroyed, and most of the time, if there are batteries in things like power tools, there's only 1 or 2 cells that really do go bad, and then the rest of them are fine. So if you can save those batteries from ending up in a landfill, and then only recycling the ones that are truly bad, you're just kind of helping things move along anyway. So I'll take any 18650 and larger size batteries. I don't like to deal with a lot of NiCads and NiMis, but I'll probably take a bit of those. So if you're interested in donating batteries, let me know. Hit me in the comments, and I'll get you the information. So, all right, everybody have a great day. Thanks for watching, and also thanks for joining me in another nerdy moment. Later.